All right, guys, we're on the back side of day 3 notes, and we talked about doing arithmetic sequences with 2 non-consecutive terms on the front side. So now we're going to do geometric with 2 non-consecutive terms on the back side. All right, remember that the 2 pieces that we need to know is the common ratio and the first term. And if we don't have the common ratio, we're going to have to go ahead and find it. However, we can't use the slope formula because slope is linear and linear is arithmetic and these are geometric. So we have to come up with a different way. So it says, since geometric sequences model exponential functions, we're going to write 2 equations of the form, and we're going to divide them is the trick. All right, so this one's a little bit trickier. So in number 5, it says, write the rule for the nth term of a geometric sequence that has 2 given terms. So what this means is that we don't know the first term, but the second term is -6. We don't know the third term, fourth term, fifth term, and the sixth term is -486. So we know it's geometric. However, we can't figure out what we're multiplying to get from term to term to term because we have that big gap in there. Okay. So what they told us to do up here was to use this formula and to write 2 equations. All right. So our first one, we're going to take out the a sub n. And we're going to go ahead and put in one of our outputs. And I'm going to take the larger number first. So I'm going to take -486. All right. And we're going to put that equal to, we don't know our first term, so that's going to stay a sub 1. We don't know our r, so that's going to stay r. And then the n is like the input. And that's 6, since I used -486. And that's one of our formulas. Okay. And then there's a -1. All right, and then remember how they said to divide them? So I'm going to use a big division bar, and then I'm going to put the second one just like that underneath, but I'm going to use this information here. So instead of -486 as my output, I'm going to use -6 as my output. Still don't know first term, still don't know r. All right, but then 2 would be the input -1. All right, and since they said divide, we're going to go ahead and divide. -486 divided by -6 comes out to be 81. Equal to a sub 1 divided by a sub 1 actually reduces to 1, right? A sub 1 divided by a sub 1 is just 1, but since there's other stuff, we don't need that, okay? And then over here, we're just going to do a little cleaning up. 6 minus 1 is 5, and 2 minus 1 is 1. And so remember, when you have the same base of r, it's going to stay r, and you subtract your exponents when you're dividing. So 5 minus 1 is 4. And take a look how clean that came out to be. So the first step is a little messy, but it cleans up as soon as you use some division. Because we have to solve for r, we have to get that 4 exponent off of there, and hopefully you remember to use your reciprocal power to do it. All right, that reduces or multiplies to an exponent of 1, and r to the first is just r. And 81 raised to the 1/4 can be put into our calculator. Okay, and we're going to end up with 3. However, it is positive and -3. There are 2 sequences we can get, but I think for us this year, we're just going to focus on the positive value, all right? But technically there are 2 sequences, so I'll show you both, all right? So technically your r value could be positive or -3, and that comes from this being an even number on the bottom, and 4 being on the bottom goes in the crack, making that an even root. And even roots have 2 answers, okay? All right. So now in our next step, we can either work backwards to get to our first term, or I can show you using the formula. All right, I'll do both. So since our r value is, let's go with +3, okay? To go backwards, you would have to divide by +3, and so that would end up being your first term of -2, right? -2 times the +3 would give you the -6. However, because we do have 2 r values, I'll just show you that your first term could also be a +2, because if your r value is -3, that would work there, right? Here, this is an r value of +3. All right. So we actually have 2 first terms, which if we have 2 first terms, we'll have 2 equations that could generate this sequence. Okay. So what I'm going to do is I'm going to go ahead and I'm going to go back to one of these formulas that I wrote over here. I'm going to take this one. It does not matter which one you take. I'm just taking this one because it has smaller numbers in it. And let's say we are going to pretend that we don't know what our first term is, okay? But we know our R value, and let's go ahead and take the positive one is positive 3. Okay? All right, we already cleaned that up. 2 minus 1 is the same thing as 1, and 3 to the first is just 3. So this becomes 3 times a sub 1, and then all we have to do is divide by 3. And we can get a sub 1 coming out to equal negative 2, okay? And so, again, that was that first one that we showed here. Okay. If we change this to a negative 3R value, then this would come out to be negative 3, and then we would be dividing by negative 3, and that's how we could get our first term to be positive 2 as well. Okay, and it all came from over here. We have one last step is to write our formula, okay, or our rule. And so we could say a sub n equals our first term, which could be 2, and it comes out to be 2 if we have an R value of negative 3. Or we could have our first term being negative 2. And if you remember that the negative 2 came out as the first term when you had an R value of positive 3. So both of these formulas could generate the sequence that we have here, okay? So sometimes we have 2. This year we're going to only focus on 1, but I just wanted to show you, okay? You'll see more of that in pre-calc when you get there. All right, number 6. It says that the second term in a geometric sequence is 10. So we could go ahead and say second term is 10. And that the seventh term is 10,240. Write a rule for the nth term for this geometric sequence to find the 13th term. Oh, then find the 13th term. All right, so because they said it's geometric, we got to use the formula and write 2 equations. So I'm going to take the larger y value and go first. So we'll say a sub n is coming out and the output value is going in. Keep the a sub 1, keep your r as r, and then this would be an n minus 1, so 7 minus 1. Don't forget that the trick is to divide. And so we'll put 10 as our output value. Keep a sub 1, keep the r, and then instead of n minus 1, this would be 2 minus 1. Okay, and we're going to divide. So when we divide there, we end up with 1,024. Remember that the a sub 1s would reduce to 1 when you divide them. And over here, this is really a 6. This is really a 1. And r to the 6 divided by r to the first power, you subtract your exponents, you would get r to the 5th. Okay, use your reciprocal power. And this one's going to be a little bit nicer. Maybe we should have done this one first because the 5's on the bottom. It's an odd root. It only has one answer, and we're going to get an R value of 4. All right, so we can now use the R value to work backwards to figure out the first term. Okay. Or we could go ahead and plug in. So I'm going to go ahead and take this formula here that we wrote, and it doesn't matter which one you take. But now that we know our R value, I'm going to go ahead and substitute it in. Our R value was 4. So this becomes 10 equals a sub 1 times 4 to the first power. Well, 4 to the first power is just 4. And then I'm going to go ahead and divide by 4. And that's going to end up as either 5 over 2 or 2.5, either one. All right, and now that we have our 2 pieces, we could go ahead and write our formula. So it would be a sub n equals my first term, which is 2.5, times my r value of 4 raised to the n minus 1. And remember, you can't clean that up. And so now when they ask to find the 13th term, I could say a sub 13 equals 2.5 for the 13 minus 1. And I could type it right into my calculator, and out comes a giant number. So we have 41,943,040. Remember, it's geometric. They model exponential, so they're going to grow fast. All right, so it should be no shocking that the 13th term is large. All right, very good, guys. Number 7 says, what is the common ratio of the sequence? So it's a little bit tricky to figure out. And we've been doing common ratio for a while. It's just that the terms that they give us are kind of funky. Okay, so we want to figure out what we're multiplying. And we know it's multiplying because they said common ratio. All right, good news. This is multiple choice, so we can use our calculator kind of as a guesser and a checker. All right, so if we take, and I'm going to only focus on the coefficients first. And I'm going to figure out how do I get from that fraction to that fraction to that fraction by multiplying. But I'm going to use my choices. All right. In choice 1 here, it looks like that you're multiplying by a -3 if we ignore the exponents. This one, you're multiplying by a -3/2. This one, you're multiplying by a -6. And this one, you're multiplying by a -6. All right. So if I'm going to, in my calculator, take 1/64, and I'm going to multiply by -3. Gives me a decimal, and I'm going to math frac it. And it gives me -3 over 64. And my second term is -3 over 32, so I don't think it's choice 1. Okay, so now I'm going to do it again. I'm going to take 1/64, and then I'm going to go ahead and multiply by -3 over 2. It gives me a decimal again. If I math frac it, I get -3 over 128, and that is not my second term's coefficient. So I think it must be -6, but I'm going to double check it. Bad news. I can't eliminate one of my choices because the only 2 choices left have that as their multiplier of -6. Yeah, when I multiply by -6, I do get -3 over 32. All right, so it's choice 3 or choice 4, and now I got to go ahead and figure out what am I doing to the variables. All right, so if I highlight my variables so we can focus on them now, I have a to the 5th, a to the 3rd, and then a. So you can see that my exponent is going down by 2 each time. If I want my exponent to go or decrease or be subtracted by 2, then where does the a squared have to be, on top or on bottom? And it has to be on the bottom. And so I think that it's number 3. So now we'll just show you to make sure you know how to find it. So if I take 1/64, a to the 5th, b cubed, and I multiply by -6b over a squared. All right, my 1/64 times my -6 is going to give me -3 over 32, which is what I need. A to the 5th, a to the 2nd is really thought of as a to the 5th on top and a to the 2nd on the bottom, which will give you a to the 3rd. Okay. B to the 3rd here and a b here is really b to the 3rd times b. They're on the same level. And so remember, you add your exponents, and that's how you're going to get b to the 4th. And if you notice, that is my second term. All right, and so we have found that it's choice 3. A little bit tougher. All right, last question, guys. Which of the following would represent the graph of this sequence? So cool thing is I know that this is linear. Okay, it looks like y equals mx plus b. Bad news, all my choices are linear. All right. Here's one thing we have to remember. Remember that there's no 0th term. Right here, this would be a 0th term. That's a y-intercept. So what they would say is that that's 0, 1. So your 0th term is 1. Well, we know that can't happen. Okay, and same thing there. Okay, and so we're left with choice 3 or choice 4. And you're going to notice that the only difference is that some are connected and some are not connected. So what we have to remember is that when they connect them, all those points on that little line segment are representing your sequence. And not only is there no 0th term, but there's no terms between the whole numbers. So for instance, this one here would be like the 1.5 term is 1, 2, 3 is 4. Well, we can't have a 1.5 term. And so we're going to go ahead and go with choice 3, where what this means is that the first term is 3, that the second term is 1, 2, 3, 4, 5, that the third term is 7, that the fourth term is 9. All right, and that's how a sequence has to be represented. Okay. All right, guys, I will see you guys next day of notes.